Great. So, hi everyone. Welcome to the MedAI group exchange sessions and for joining us today. Seongsu Bae, we have Seongsu Bae with us here to present his amazing work on EHR research. He's a second-year PhD student at KAIST, Graduate School of AI, and he's advised by Professor Edward Choi. His research focuses on multimodal learning, healthcare AI, and the evaluation and benchmarking of AI systems for deployment. He's dedicated to developing and assessing AI models that can understand both multimodal EHR records, which include structured EHRs, as well as medical images and reports. And recently, he also completed an internship at Microsoft Research Asia, focusing on multimodal question answering and generative models in the healthcare domain. So thanks so much, Seongsu, for joining us here today. And I guess just before we get started, do you want questions during your talk or would you prefer them all at the end?
I would prefer to anytime you can interrupt me. Yeah.
Okay, perfect. So let's make this session as interactive as possible. And without further ado, let me hand it over to Seongsu.
Yep. Thank you. So yep. Thank you for having me here. So today I will talk about my recent research work, which is called EHRXQA, a multimodal question answering datasets for EHRs with chest X-ray images. And actually, this work published on the newest dataset benchmark 2023. And there's another awesome first co-author who is Daeun Kyung, which is here. And there are several collaborators across the KAIST AI and then Microsoft teams and then Seoul National University Bundang Hospital. So before we get into the EHRXQA, this research work, I will briefly explain about what are the EHRs and EHRQA works, and then for those who are not familiar with the EHRQA, I will make an overview for the EHRQA for the recent research works. So EHRs are contain the patient's entire history across the demographics or medication allergies, immunization status, rep tests like that. And these are the mainly stored in the huge relational database, but also they collected the clinical notes or radial images like unstructured data format or even vital signs. So I call these EHRs as a multimodal knowledge source, which is holds various data modality. For example, texture modality, they hold the clinical notes, and then the imaging modality, they hold the radiology images like that. So so just imagine the like medical ChatGPT deployed on the hospital database. So we can imagine that an intelligent AI that can understand the entire EHRs, and then they can answer the user's questions based on the EHRs like that. So users send them into the EHRQ system with natural language utterance, and then the EHRQ systems look down the EHR database itself, and then they just get the answer from it and then convey the results to the users. And then this entire process make the entire workflow efficient and then effective way to interact with the EHRs, or we could just hospital knowledge source. So in my thoughts, EHRs as a rich information resource in a QA format. So, for example, what was the last known blood pressure of these patients? These are the patient-centered facts. And for example, another example for is how many patients were admitted to the COVID-19 in 2020. And also we can ask about can Dr. Kim see more patients today? So these are the QA formats, but they can deliver the very rich information resource to the end user. And an AI model or intelligent machine that can understand EHRs and can answer such questions can help many users like physicians, nurses, administrative staff, or even patients. So mainly this AI machine can support clinical decisions or foster clinical research on the EHRs, and even enhance the hospital administrative operational efficiency. So that's the application aspects of the EHRQA machine can evoke the meaning of their usefulness. And another aspect is that for AI aspects, so EHRQA benchmark can serve as a test bed for evaluating AI's capability to understand EHRs. So if the AI model understands EHRs, which means that they can solve this kind of the EHRQ benchmark as 100% if the data set was well constructed. Yeah. So these are the recent survey paper. It covers all the recent EHRQ works, and they showed up these timeline figures. So the entire number of the studies on EHRQ over the clinical order. And as you can see from the 2011, they arise at the new research topic about the EHRQ, and nowadays it's more than like 10 or 12 per year. And I think these recent research paper are limited on the table and text modality. But if we cover the image modality or signal modality, there are more than these kind of the diagrams here. So I prepared the recent EHRQ works, not only the timeline, I mark up for each data sets and with the colors. So for example, the red colors means that the QA data sets on the structured EHRs. And the green colors is the question answering data set on the clinical notes. And then the blue one is the medical imaging studies. Medical visual question answering data sets. And the gray one is a recent rising data sets, the ECG-QA, which is also published in our laboratory. And these are tackles the the signal data from the human body, which is a ECG. And as you can see, there are a bunch of the data sets, and each data set flows evolved across the data modality. And nowadays, for example, here, as you can see, the red color and then the green colors are mixed together, which means that the multimodal EHR question answering data sets. So the drug EHRQA is the first multimodal EHRQA data set, which mix the MIMIC-3 tables and then MIMIC-3 notes information, and then they just ask about the drug information from a patient using the two the route. For first one is doing the text to SQL task on the tables, and then the other thing is the clinical machine reading comprehension on the clinical notes. So they get the information from each route and then merging. If the one results is more shareable, then they choose that kind of the results from one modality here. And then the MedAI is also the multimodal EHR question answering datasets, and they tackle the same scope of tables and text. And our research work is on the other side. So we merge the image and then table information. So as you can see in the color, we consider the two modalities from the images and then the tables. So yeah. And as a side effect, we also build a very complex medical visual question answering data sets called MIMIC-CXR together. Yeah. I believe the evolution of the question answering data sets on the EHRs they mostly depending on which data modality within EHRs is accessed. Most studies have proceed by proposing methods and then data sets suitable for each modality because because the methods are usually limited on the data sets and the benchmarks. So for example, these kind of the EHR question answering data sets are categorized into 4 areas. For example, the structured EHRs, which is a table-based EHRQA, and then the other thing is clinical images QA, which is a medical visual question answering data set. And we can imagine for structured EHRQA as a semantic parsing task. Once the AI model translate the natural language utterance into the SQL query, and then the SQL query can be executed by the SQL engine, and then they get the results, and then the results can be shown to the end users. And for example, the clinical images, we just train the medical visual question answering model, and then just as an input with natural language image, natural language utterance, and then the clinical images, mostly the singular or 2 sequential images, and then get the results from the decoder or the class multi-head classifiers like that. So
Can I ask a quick question here, Seongsu? So are most question answering datasets, including yours, do you focus on like information retrieval and reasoning from the datasets, or do you also do things like risk assessment? So can I ask a question like, oh, what's the risk that this patient is going to have something in the future? Like what kind of...
So that's the good question. So for my thoughts, for the dataset benchmark for understanding EHRs, the basic step is that to retrieve something from the EHRs, not predict the future events or even understanding and get the results for implicit results. So once the AI model get the perfect score or even 90% score for the retrieving something, the behaviors, and then next step, we can make a challenge for the predicting something or make it like what are the missing data for this timeline like that. So I believe, but the the most research dataset benchmark so fast, so we don't have time to measure the dataset benchmark can go 100% or not. But I believe we should look down into the retrieving information from the EHRs first, and once we got the good performance on that, then we should turn into the other benchmark, as you said. Yeah.
That makes sense. Thank you.
Yep. So that's the main background about the EHRQA. And I want to mark for 2 axes, so which are the main research scope for our research. So first one is a structured EHRs, and then the second one is a imaging modality for chest X-ray images. So first one is I want to explain about the brief history about what we select the main ingredients for our data sets. So first, there's a MIMIC-CXR data set research work from Wang, and this is the first EHRQA data set constructed based on the MIMIC-3, and they use the text-to-SQL modeling, which is commonly called semantic parsing task. So as you can see in the left figure, there are the bunch of the tables for here, and they showed up just demographic and the procedures from the MIMIC-3. And then once we talk to the AI model for question, how many female patients underwent the procedure, blah, blah, and then the AI model can generate the SQL query like this part of it. So this is the first EHRQA data set presented the 2022. And then after that, I built a model for the uni-QA, and then this uni-QA model get the QA performance on the test data sets of the MIMIC-SQL star, which is the complex version of the MIMIC-SQL. And the MIMIC-SQL data sets, the performance gets almost saturated because the failure cases are coming from the human annotation error mostly. So the MIMIC-SQL is not enough to measure the understanding EHRs or QA benchmark. So one of our laboratory research work, also I've joined as a co-author of this research work, the EHRSQL. And the EHRSQL is the more advanced version of the benchmark for the structured EHRQA data sets. So there are some first things, and I want to mention about the most of them. So they actually conducted a very comprehensive survey from the more than 200 people from the hospital staffs, and we collected the around 174 question templates. And these data sets also cover two open source EHR data sets, and they include the unanswerable questions in the text to SQL task, which comes from the survey. And also there are various time expressions in the questions, which is very practical, like last hospital visit or yesterday or since 4 years ago, like that. And then also we include the very complex SQL query compared to previous database-based question answering data sets in the general domain. So for example, like asking N-year survival rate for the patients like that. So and also they propose a trustworthy or reliable text to SQL task, which should abstract make results as an abstract when they meet the unanswerable questions. And I believe this data set is quite comprehensive for now. So we are more focusing on these templates as a base ingredients for our multimodal EHR question answering data set. And for the motivation of our research work, even these question answering data sets are very complex and comprehensible, but they cannot handle the image information because they just only consider the structured EHRs for their research scope. So I want to expand these kind of the data sets into multimodal EHR question answering data set. And for the image side, there are a bunch of the medical visual question answering data sets, and they are usually ask about the image specific information. For example, what does the CT scan of thorax show, like that, and then or just they ask about very simple stuff like modality or plane, which is very simple. And yep. Oh, yeah. Thank you. And yeah, so these are the main data sets from the medical visual question answering. And previously, like 3 years ago or 4 years ago, there is a data sets using the MIMIC-CXR called LOD with dialogue data sets, and they are tackling the medical dialogue setting. But I think it's quite simple for checking the image understanding for AI model. So and also there are many interesting research work on the medical visual question answering, such as a dialogue or the patient-centric question answering data sets. But that none of the data sets consider the EHR itself, or they don't consider about combining integrating the EHR information with the medical images. So that's the two bridges that I consider. So first one is a table-based, and then the second one is the image-based EHRQA. And then considering both natures and then merge them as a one question answering data set called multi-modal EHRQA data sets. So yeah, the main limitation is current EHRQA systems focus on uni-modal information, overlooking the EHRs inherently multimodal nature. So for example, the EHRSQL, they suggest the text-to-SQL modeling or even the MIMIC-SQL datasets. Also, they just formulate entire problem into the text-to-SQL modeling, but they cannot understand or handling the image information or even the unstructured information from the EHRs. So they only can handle this kind of the route about the table information. Or for example, medical visual question answering data sets, they cannot understand table or tabular information from the EHRs. And even we just set up the given the patient ID, blah, blah, like that, they cannot handle those kind of the retrieval systems by just using the medical visual question answering model. So I believe to utilize the EHR's potential, so it is really important to develop the versatile QA systems that are capable of the seamless navigating across the entire modalities of the EHRs. So our research goal is based on the two aspects. So first one is build a multimodal EHR QA benchmark using the good ingredients across the tables and images. And also using that QA benchmark, we should like suggest the nice baseline which are not limited on the data modality, single data modality within EHRs. So that's the our main project goal of this research. And the overview of our research diagram is like that. So using the two data sets, MIMIC-CXR VK, which is made by ours, and then the EHRSQL, which is presented in the 2 years ago, and using both natures, so image and tables, we can generate our data sets, which is a EHRXQA, a multimodal EHRQA data set, and then they contains a very diverse question answering scope, such as image related question answering or image table related question answering or table related question answering. So as you can see in the image related question answering, it's a little bit tricky because for most of the medical visual question answering data sets, they just ask about the list, as you can see here, list all common abnormalities in both the lab lung and cardiac fluid. So they are not on the fly setting because they just given the image or given two images like that. So they already know about the image ID information, not retrieving the two images or singular images given the natural language questions or utterance. So I made up the very complex setting about and practical setting to retrieve the image information as a two-step. For example, for the last hospital visit of the patient 42, so the model should retrieve the some specific image IDs or images information from the border part of here, and then they activate their visual perception ability using these kind of the utterance, like as mostly done in the medical visual question answering benchmark. And in the table related question answering, they looks like similar to EHRSQL because we just conversion to the from the MIMIC 3 to MIMIC 4. So the most of the question answering templates are similar. And as you can see, the patient for it to undergo a lab procedure in the last hospital visit. So it looks like simple, but there are very challenging parts. So they should match up the condition value exactly to the table information. And also they, as I mentioned the previous slides, they consider the time related information, time related expression. So the last hospital visit is should conversion to the appropriate SQL query expressions. So it is really hard to generate those kinds of the expressions just given the EHR information. So, and both considering into the image table related question answering. So there are some logical paths. So for example, after events or before events like that. So as you can see in this example, did the patient undergo some specific procedure during the last hospital visits? And then there's a after condition for related with the X-ray specific condition. So they look down into the X-ray information and then also the table information. And they also considering the temporal order of two different data modality. Yeah. So yeah, that's the overview of our new data sets, EHRXQA. And
One question here. Do you also include like unstructured reports of these images, or are you planning that in some future iteration?
yeah, it's very core question about our research work. So as you mentioned, the MIMIC-CXR or even the radiograph, they mostly hold their corresponding reports, which is a textual representation, and it might more suitable for retrieving information from the reports because they're the physicians' opinions, and then they are more pretty matching with the table information. Because of the table information, they wrote down the textual information. So mostly using the large language models, we even the table information, we just linearize all the table cells into the textual representation. So I hope the textual representation provide valuable information compared to image, but we include, yeah, that's the main consideration for when we constructed image related questions. So there are some visual content not in which is not in the report. For example, the mediastinum and then the thorax ratio like that, and then these are not main features written in the radiology report, but the mostly radiologists check about the ratio to conclude the cardiomegaly or mediastinum related with pathologists like that. So we add up some visual related the contents into the question templates. So the AI model should retrieve or perceive some information from the image itself. Yeah, but I believe including texture report together as a proxy, or I mean the triple modalities to understand the EHRs, then I believe that the performance of these data sets, I mean the performance of the AI model should increase. Yeah. And that is another research direction. Yeah.
Got it. Okay, thank you.
Thank you. So there are yeah, so these are the overview of our research work, and I briefly explain about the approach that how we construct the EHR multimodal EHR query data sets. So the main starting point is that we consider the uni-modal EHR question templates, and then starting on the question templates for image and then tables, considering both natures, and then we build the multimodal EHRQA data sets. So a little bit complex and tricky, but I will explain about the uni-modal EHRQA first, and then move on to the multimodal EHRQA. So there are three data resources about the what we consider. Actually, these are the only possible option for open source data sets for currently, but I believe the other institution can open source the multimodal EHR, and then we maybe we can build another benchmark using our the dataset construction process. Yeah. So first one is the MIMIC-4 as colored in red, which means that tabular information. And then the MIMIC-CXR, which is a X-ray images database. And there's another data set called Chest ImaGenome, which is the structure information of the MIMIC-CXR. So what we want to build these data resources is that from the table, we can generate the table-based EHR question templates. And then from the image part, we can generate the image-based EHR question templates. So yeah, the main strategy is from the uni-modal to multi-modal. And first one is a table part. So as we mentioned about before the background of the EHRQA, so EHRSQL is the most comprehensible table-based EHRQA dataset. So we use their question templates for the MIMIC-3, and we cannot directly use the MIMIC-3 question templates because we are targeting to the MIMIC-4. So we have some conversion process from MIMIC-3 to fit the MIMIC-4 setting. So there are little bit the fine-grained modification about the question templates, and we got the around 174 question templates for the MIMIC-4 database, and we do not consider the unanswerable question templates from the EHRSQL, which are not the main research scope for now. Yeah, and from table part, we get the bunch of the question templates adaptable for the MIMIC-4. And for the MIMIC-CXR, we consider the MIMIC-CXR datasets and then the chest ImaGenome. Then we build the new medical visual cancer answering datasets called the MIMIC-CXR VQA. And yeah, the MIMIC-CXR is the very large scale of the chest radiographs. And these data sets can be connected with the MIMIC-4 right now. And then because they share the same patient IDs, which is a subject ID. And the chest ImaGenome is another data set, but it's the fine-grained structured label information of the MIMIC-CXR. So they have two data sets, which is called silver and gold. So silver data sets is automatically generating by the machine learning and then the human rules from the report. So for example, there's one CXR image, and then so for example, there is one CXR image, and the chest ImaGenome holds the structure information like this kind of the knowledge graph. So we can track the which information is related with these specific study. So for example, a patient has several studies, and each study has multiple images, like a PA or AP or even lateral, and there are a bunch of information related with the several categories, which are the anatomical findings or disease or medical device like that. And then we know about which labels are present or absent. Using these CXR features, we can generate the medical visual question answering using the question template format. So we curate the diverse medical visual question answering question templates as presented in the right-hand side. So for example, are there any disease in the left lung like that? So we just made up the question template in the fill in the blank style. So first one is we build the initial templates and then add the logical or set operation rules, and also add the clinical factors like the ratio or the some categories borrowed from the previous medical visual question answering research work. And now we have a very large scale of the seed templates, and using the GPT-4, we have diverse paraphrase templates starting from the very small scale. So it's a very straightforward to generate the medical visual question answering datasets by using the CXR features and then the template information. So for example, we just sample a template. So is there attribute in the object? And then we also sample the arguments as left long and then lung cancer. And using the CXR features information from the chest ImaGenome, we know about these actual answer is yes or no, like that. So yeah, that part is might be program execution here. So we know that there are sampled arguments and the sample templates, we can generate the question. And then also we just sample the image, and we have two sampled arguments for image and then the question. So using the question information and then image information, we can generate the answer by using the predefined program by searching the CXR features in the chest ImaGenome datasets. So the final results might be, is there lung cancer in the left lung? For the study ID this, and then the answer would be yes. Yeah. So I believe the most of the visual question answering dataset using the question templates by filling in the blank style, they usually use this sampling strategy. Yeah. So we build a MIMIC-CXR big data sets using the 48 question templates, and then yeah. I think there are very good QA resources on the MIMIC-CXR right now, but last year, I believe the middle of the last year, there are no data sets related with the MIMIC-CXR. So yeah. So just in case we want to test about the performance, QA performance on the MIMIC-CXR VK, like the conventional process about the medical visual question answering task. So we just formulate the multi-label classification with the around 100 distinct answer labels. And there are 3 baselines we've considered: PubMed clip, and then the MedBuild, and then the M3A model. And there are 2 main evaluation metrics with the new metric called propose for the reliability of the measurements. But I would skip this part because it's a little bit long to explain about this. And yeah. So the results are straightforward because the M3A model is the state-of-the-art model for across the among these kind of the models. And as you can see in the category, there's a 7 categories in our data sets. So plain and gender, size, abnormality, anatomy, and attribute presence. So plain is just asking about the AP or PA view or like that, or gender is this image a male or female, like that, or size is kind of related with the ratio information, for example, cardiac to thorax ratio or mediastinum to thorax ratio, like that. And these are the very easy to predict because they are their space to predict, it's quite small. But for abnormality or anatomy or attributes like that, these are the very hardest category for to predict the answer from the only single image. Yeah. So the main bottleneck for understanding a single medical image is that which part and which attributes contribute these specific X-ray information. And the presence is just a binary question, yes or no. Yeah. So it's more easy to predict as a just binary classifier. So using two what we made in the uni-modal EHRQA. So first one is a EHRSQL MIMIC-4 version of the question templates, which are very comprehensible for the table-based EHRQA. And then the MIMIC-CXR QA tackles the imaging part. So we have two weapons to construct the multimodal EHRQA dataset. So yeah. First, we start the database construction. So for the MIMIC-4 and then the MIMIC-CXR, we can build a new multimodal database, which actually stored in the like a real hospital environment. So we can make a new integrated database using the predefined table called TB-CXR tables, which stored in the main structure information like a subject ID, hospital admission ID, and then the study ID like that. And then they also include the DICOM ID, which is image ID. So once we have a chest X-ray image storages like this, then we can connect and retrieve the real pixel level information by using calling these DICOM ID for example, like at SQL query. And yeah, as I mentioned in the chest ImaGenome, there are two main natures. So we built two database for seeable database and then the gold database. And seeable database consists of the 800 patients, which were used for training and validation. And the gold database with 400 patients will be used in the test bed for our data set. So yeah, the main part is that the question template construction for our data sets. So these are the main scope. And there are two axes we've considered. So for example, the modality base, they include the image and table and image plus table, which is multimodal. And there are sub-axes for patient-based scope, which is a single or group or none. And as you can see in the, I will explain each example in the next slide. And also in the EHRSQL datasets, they consider the real practical meaning of the temporal expression in the user's natural language utterance. So we also mimic their the temporal value about using time filters or time expressions like last year or within the same hospital visits. Yeah. So for the image part, as you can see in the single one image, unlike the conventional medical visual question answering, we add some integrated expression to specify the target images, like given the last study of the patient number, blah, blah, like that. So given the EHR, entire EHR, and then the natural language, only the natural language utterance, the AI model should retrieve the image information and also the predict or perceive the corresponding visual components in the natural language utterance. So it's a little bit hard because these are the on-the-fly setting. And there's another sectors we call two-image. And these are the very important things that mostly happen in the CXR studies. So compared to consecutive CXR studies. And also, these are very hardcore QA scope. So we also consider the N images and group images. So how many times has the chest X-ray of the patient shown specific pathology in the specific information in the specific temporal expression. So AI model should retrieve the multiple images and then predict the multiple images. Yep. And for the group, they also consider the discrete operation like count or max like that. So they can counting the number of the patients for the specific image condition values like showed up the any anomalies in the media stream like that. Yep. Yep. A similar process in the tables, but table is straightforward because usually we just using the text to SQL for the relational database and get the results. And these are very familiar for the normal like EHRQA questions for table-based EHRQA. And yeah, for the multimodal case, this is also very hardcore question answering scope. So for example, did a chest X-ray study for patients reveal any anatomical findings within the 2 months after the precision of prescription of since blah, blah, like. So we consider the cause and effect relationship. Mainly we consider the cause and effect relationship with the imaging modality and then the table modality. So for example, first case, co-occurring the table and CXR events. For example, retrieve the patient co-occurring the specific procedures and then specific imaging imaging conditions like that. And also we can consider the CXR event following a table event or vice versa. And these are the main clinical assistant decision making for when the physician look down the both modalities like that. And also there's another features that we consider the code analysis, but not only the table information, we can consider the visual part. So for example, like combining the demographic factors with CXR findings. So count the number of female patients who have visual features like that. So this led to around 80 templates for multimodal scope. And I believe this is the good initial start for simulation for the multimodal EHRQA datasets. Yeah. So that's the main dataset construction. And this part, it's the approach that we made. And I think it's quite straightforward for when understanding the once you are understanding the SQLs. So the main SQL's limitations is that they cannot handle the unstructured information. So we've just inspired the recent work Binder. We propose a new method called NeuralSQL, and these methods can retrieve the unstructured information and also the structured information, or mixing the both information based on the expanded representation of the SQL grammar. So for example, so there's a question template called given the, for example, the first study of the patient in the time scope, is there lung cancer in the lab lung like that? And there is a visual information here. So we just transform into the neurosymbolic representations, which can integrate with the structured data retrieve the query like SQL. So that's why we call NeuralSQL. So so for example, they retrieve the structured information from the table-based EHR, structured EHRs, using the SQL query first, and then using that structured information, we can use the transform function called funcVQA, and these funcVQA can hold the image IDs tables as a temporary table. And also they have arguments for the visual arguments as a VQA format. So is there lab lung in the is there lung cancer in the left lung for these T1 dot study ID, then this function can call the AI model to predict these question answering instance for each instance of these columns. So once they predict the information, then we can use them as a structured tables as a temporary. So for example, the main question is that count the number of the times that patients had a chest X-ray studies, lung cancer in the left lung in the last hospital visit. So it's quite complicated, the query. And using the NeuralSQL parser, which is just using the large language models like a GPT-3 or ChatGPT, and we can parse this kind of the question into the NeuralSQL format. So this NeuralSQL format hold the new syntax, but which is expandable expression. So it's compatible for the traditional SQL grammar. So these are the transform function called funcVQA. They hold the two arguments. First one is a natural language question, which is a sub questions in the main question and related with the only visual part. And the second argument is the constrained column reference as a referring image IDs or image information. So once we got the NeuralSQL by using the GPT or ChatGPT like that, then we move on to the execution part. So there's a NeuralSQL interpreter we made. And these are the SQL interpreter with the visual question answering model or visual question answering API. So they once parse the execute their NeuralSQL information on the interpreter. Once they meet this specific expression, they call the VQA API, and then with the bunch of the study IDs, the VQA API model predicts using the natural sub questions for each study ID, and each study ID can retrieve the pixel level information from the X-ray image data storages. So we can predict each CXR image into the VQA model with the sub questions, and then we get the results like true, true, false, like that. And then we got the temporary tables, and then these are the structure information also. So it's compatible for the SQL interpreter, and we get the results like 2. So there are 2 times of the specific multimodal events like here. So yeah, that's the main framework about the NeuralSQL we made. Yep. So yeah, that's the main approach for we've proposed in the NeuralSQL. So for table related question templates, they don't have any visual information, so they don't need to annotate the NeuralSQL new methods. So we just annotate the corresponding SQL queries. And then for image related or image plus table related question templates, we annotate the appropriate NeuralSQL templates. So that's the final page for solving our EHRXQA task. As a baseline, we can provide the 2 types of the or even we can just say 1 type of the neurosymbolic representations. So for the questions and then the NeuralSQL or SQL, so and get the answer from it. Yeah, as in here. So after the very complex data set generation process, we get the question and then the SQL or NeuralSQL, or just we can call NeuralSQL because the NeuralSQL is an expanded version of the SQL, and then the answer. So these are the main instance formats of within our data sets. So we have around yeah, here. So around 50,000 instances for question and NeuralSQL, and then answer triples. And as you can see, in that time, there are no data sets, or there are only one data set called drug EHRQA. So, and we also consider the very diverse question answering scope. Even we include the group-based image or multi-modal query like that. So, and also we have a very compositional part for the visual and also the table. So it's very complex and diverse information seeking needs the data set hold. And then this is the first attempt to merge image and tabular modalities in the medical question answering. So yeah, I think the time quite a lot, spends a lot. I move fast to the final results. So yeah, maybe 4 or 5 slides left. And basically, our data sets can be solved as a semantic parsing currently. But if the other researchers want to solve the problem not using our NeuralSQL, or just not semantic parsing, just predicts directly or not like that, it is possible to measure the performance on our data sets, because we have 3 evaluation protocols. So first one is a logical form accuracy. So we just measure the predictive program versus the ground truth program as a string match. And then the second one is a ground truth execution accuracy. Once we got the program and compared to the predicted answer and then the ground truth answer, this metric is very important to measure the visual perception, because once we got the GT query for table-based EHRQA, then the execution should be 100%, like in the table. But for the questions which hold the visual part, then the execution means that the prediction of the perception of the visual information. So the performance getting very lower. And the final evaluation protocols, which is the predicted execution accuracy. And these are the main overall accuracy to measure the entire pipeline, given the questions and the EHRs, and then what are the accuracy for the predicted answer, get through all the passes. So we just build a very simple but effective baseline. So we combine the semantic parsing model using the ChatGPT, and then using the VQA model, which is trained on the MIMIC-CXR VQA. And because of the MIMIC-CXR VQA, we believe that kind of medical visual question answering model is the state of the art to understand the visual information for the X-rays. And we use that just experiment 2 different prompting strategies. So first one is just fixed. So use the fixed and shots questions query pairs as a demonstration, or we just called like few shots learning in the GPT-3. And then another is that more towards dynamic prompting. So just using the BM25 retrieval methods. So we use a retrieve and shots question query pairs from the training question answering data sets. It's more straightforward to get the performance getting up high. So yeah, so the main results like this. So we use a old version of the GPT-3 Turbo with the medical visual question answering as an API. And then as you can see in the fixed prompt, it's really hard to get the appropriate performance on this benchmark. But in the this retrieval dynamic prompting, we get the just not bad score for the especially logical form accuracy. And as you can see in the table related question answering performance for the execution per ground truth query, they hold the 100%, because once you got the ground truth query, then the interpreter should generate the perfect matching answer. But in here, image related or image plus table related questions, it is really hard to get the good performance because we have a very hardcore question answering scope, like group based or even the multimodal group to get the good performance. Yeah. So yeah, that's the main the contents of our research work. So we introduced the MIMIC-CXR VQA and also with the EHRXQA, which is the main data sets for multimodal EHRQA datasets, covers images and tables. And also we propose a NeuralSQL based approach. I believe this kind of expression or mechanism can expand to understand or access the data of EHRs on the fly. Yeah. And I think these are the very important features of our research work. So for the limitations, there are only single possible options for choosing the EHR database, which is a multimodal. So I think the generalizability a little bit limited on for the evaluation part compared to EHRSQL. For example, EHRSQL, they hold two databases, MIMIC and EICU to test that as a test bed, but we have only one, the MIMIC nature. And also, we use the Chest ImaGenome's labeling strategy, which restricts the detailed visual analysis, like a tumor size like that. And also, we left up the answerable questions so that a little bit reducing the practicability and utility compared to the EHRSQL. So as these handling the limitations, I think the for the future direction is 3 steps. For example, there is a multimodal dialogue systems for EHRs, because of the EHRXQA questions looks like a quite complex to type or saying it. So I think these kind of steps can be spread into the sequential steps for the sequential QA formats. So yeah, we can imagine the multimodal dialogue systems like for recent instruction tuning or whatever like that, using the large language models. And we can also establish a reliable multimodal EHRQ systems, adding the ambiguous images or even the ambiguous questions like that. So there are several things for adding the adversarial samples for our data sets to test bed as these AI systems is reliable or not like that. And then we also expand the tri-modal EHR data sets to broaden the capabilities of the EHR QA model. And I think the basic step is that using the radiology report and then the images and then tables to make more better scope or better QA performance compared to current version of the EHRXQA datasets. Yeah. So yeah, that's for today's work about EHRXQA or multimodal question answering datasets. And thank you for listening about this work. Thank you.
Awesome. Thank you so much, Seongsu. I think that was a great talk, covered comprehensively from where the state of the field is and then all the current approaches and your approach as well. I guess before I know we are a little out of time, so maybe we can have time for some questions if there are any from the audience. But before we move on to questions, let's give our speaker a round of virtual applause. And thanks Seongsu again for the great talk.
Thank you for your invitation.
Do we have any questions from the audience? I guess I can actually start with one. So right now, like the power of the multimodality really comes through when you combine images and tables. But let's say I want to have a different type of image data that also needs to be incorporated.
Yep.
So let's say CT images, for instance, are very different from chest X-ray. Will your like data set generation process, can it be adapted for like other types of imaging modalities also, or would that be
Yeah, that's awesome question, because these are just limited on the X-ray images, even the chest X-ray. So as you mentioned in the template structure with the data set construction overall process, I think once you have a good ingredients, which means that the parsing information or label information is adaptable for this kind of the concepts, because this kind of concepts, I believe that most of the medical visual clustering, or even the general visual clustering, because we've studied the clever data sets, which is a very famous in the visual clustering data set on the general domain. I think there are main linguistic aspects to ask about the visual queries on the image has a similar the component. So, for example, once we build the arguments, two arguments, and we can just connect with the conjunction or disjunction like that. So the entire process, once you got the good ingredients or good dictionary mapping, I believe this generation process can be done in other medical modality, for especially the image.
Got it. And do you think any, like for instance, there could be a new set of questions that you can ask for, like a 3D imaging versus, let's say, 2D imaging? Would that just, you can just add it along your set of templates? Is that how it will work?
Yeah, I believe these steps are very the baby step to understand the entire even the medical imaging modality, because mostly the physicians, they ask about the specific radiological or visual components to the image as same. So they have a instinctive understanding when they perceive the image as their eyes. So I think it's really hard to get the field knowledge they done in their real world process, but that's the future goal with for the researchers who are interested in the make these kind of EHRQA benchmark or EHRQA understanding towards more better way to adaptable for the clinical field. So yeah.
Awesome, thank you. Do we have anybody else in the audience who wants to ask a question? Okay, I guess if
I have a
oh, sorry, go ahead.
I have a quick question. Thank you for the presentation. Thanks, Seongsu Bae. And by any chance, was there any specific reason that you didn't use the Chexpert dataset instead of using the MIMIC dataset by any chance?
Yeah, that's very good question, because of the I think the Chexpert dataset, it's really great because they have an initiative for the radiology report parsing or label problems like classification or multi-level classification. But I've done very comprehensive analysis for where is it? So analysis for the comparison between the chest imagenome or Chexpert or other labelers. So for chest imagenome, I believe the chest imagenome is a little bit improved version of the Chexpert datasets. So the label reliability or label accuracy precision have much more better, not much, a little bit relatively better than the Chexpert datasets. And also, we want to make the visual question answering datasets as very complex. So chest imagenome has a very diverse features. For example, anatomical locations and So for example, there are a very bunch of the arguments which in the chest imagenome. So these are very diverse information which covers mostly the radiological pathology findings. And compared to the Chexpert, it's much more, a lot of labels. Yeah.
I see. Yeah. Thank you so much. Yeah.
Great. Any last questions before we end the session? Okay, so if not, thanks again, Seongsu, and for the great presentation. And then we'll have this recording up on YouTube, and we will see you all next Monday. So just a note that our regular timings are now shifting to Monday. So hope to see you all. And yeah, Seongsu, and then if your co-authors and in your lab also wants to join us, like I know it's a very early time for you guys, but hopefully at least you can catch it on YouTube or something.
Sure. That'd be great. And I want to mention about one things before ending up this
Sure,
great
yeah.
talk. So yeah, so we in our lab actually starting from the EHRSQL, we have great resources about the EHRQA benchmark, and then the understanding how these systems should be involved into AI model or like that. So we have a shared task for reliable text to SQL modeling on the EHRs, and the professor Edward Choi, and then the Gubok Lee is the leading principal, the professors and then the students. So if you are interested in the testing your good large language models, or even just small language model with the adapted with the unanswerable questions or Epstein methods like that, then you can just join and then test your model in here. And yeah,
Sounds great.
yeah, thank you. And yeah, and I will share the link about these presentation materials and then the abstract also. Yeah.
Perfect. Thanks everyone for joining. Hope to see you all next week.
Thank you.